Hello, my name is Sean, and I'm joined by Katie, Matt, Sonia, and Sawyer from Team 7. We are here today to present our ME452 interim presentation regarding our design project. So, our product of interest that we are examining is pencil sharpeners. Specifically, we'll be examining an electric pencil sharpener. For standard electric pencil sharpeners, the basic procedure is that the pencil will be pushed into contact with the blade, and the blade will be engaged, sharpening the pencil as it remains stationary. Here on the right is a quick glimpse of the pencil sharpener we're examining. Next, we'll be talking about our customer base. Our primary customer group will be students. This includes students from K through 12 up to university level students. Our secondary customer group will be artists, which includes anyone who will be frequently using sharpenable art utensils. We expect our primary customer to purchase more in a greater volume, so we expect about 54,000 units per year for students and 36,000 units per year for artists. And to conduct our functional analysis on our product, we created a fast diagram after identifying the functions for our pencil sharpener. We decided to have a sharpen utensil to be our primary function and decided that shape utensil and hold utensil are the primary functions for the diagram. We also placed a large emphasis on supporting functions to ensure our product would be pleasing to use.
In assembly sequence analysis, sequence 1, we propose starting the assembly with the lower body and the battery cover. Following these are 3 subassemblies: the motor cover subassembly, which includes the motor cover and 3 metal inserts, the motor subassembly, which includes the motor and battery housing and the sharpener gear, and finally the blade subassembly, which includes the blade, spring loader, and blade casing. Following these, the transparent cover and main body will be added on top of the subassemblies. In assembly sequence analysis, sequence 2, we propose starting the assembly with a sub-assembly consisting of the lower body and battery cover, followed by the transparent container. Next, we propose adding 2 larger sub-assemblies: the motor cover sub-assembly, which consists of the motor cover and 3 metal inserts, and then the motor sub-assembly, which consists of the motor and battery housing, the spring loader, blade casing, sharpener, and sharpener gear. Finally, in this sub-assembly sequence analysis, the main body will be added on top. We created a comparison table to compare the benefits and drawbacks of each assembly sequence in order to determine which is the most viable. We determined that sequence 1 was stronger in all categories with the ease of testing subassemblies, because in sequence 2 there was less subassemblies to test.
Here is a breakdown of our components and their functions. Some components, such as the blade subassembly, help complete many functions, while some functions, such as reducing vibrations, are assisted by many components. We will be using this tool later to understand the potential impacts of component redesign on product functions. Next, we have our bill of materials. We have a very rough estimate of the total cost to be $43.25 per unit. This is a rough estimate because we only have half of the assembly and tooling cost estimation finished, so we can assume that the cost will most likely be higher. However, we have also noticed that our material and processing costs are quite high, but it's mostly due to a few individual pieces that are injection molded. So we will be looking into those pieces and might need to increase the estimated amount of production so that the total cost per unit is lowered.
For functional differentiation, the functions that are identical for both customer groups are going to be pretty much anything that goes into sharpening a standard writing utensil, as both groups are going to be doing that with our tool. The functions that are going to be different are going to be mainly for the artists, who are going to be using a variety of different writing utensils, different sizes, things of that nature. So they need more versatility there. For our component commonality, most of our parts are going to be under platforms because those are going to be ones associated with sharpening pencils. The main difference, the module, is going to be the size selector. So the artists are going to be able to select a variety of different tool shapes and sizes that they can use with our sharpening utensil.
Here's some images of our component design. We added a spinning attachment that allows for size variation so that our secondary customers can use it to sharpen pencils and writing media of different sizes. The attachment locks into place by falling into designated notches set into it. These notches fall into the protrusions added to the body of the sharpener. Moving on to the interface, we added a clearance hole to the main body and are attaching the spinning size adjustment piece with a screw and a nut. The assembly sequence is mostly the same as compared to the original. The new sequence has a different ending where the spinning attachment is attached to the main body before it's clipped to the rest of the sharpener. Thank you.